Hello guys. I had a viewer come by yesterday that lives all the way down there in Florida, and he brought up some items and actually picked up a couple of items, and that was viewer screen name is B Blood. He remember, he's the one that won the function generator, the NIU, I believe it was, function generator. Well, anyway, him and his wife came down yesterday to visit and drop off some stuff. Now I'm shooting with the new Canon camera, and this will probably be, I've already done some recordings with it on some more videos and archiving that footage for future videos, but this will be the first release video using this camera. So let me know in the video how the quality of the audio in the video is compared to the other cameras I was using. Now he dropped off this real nice looking icon. It's an IC22U. So he said he thinks it works, and if you notice, it's got the push buttons to set the frequency span with. And I had a handy talkie years ago that was similar to this, so it'll be interesting to get inside this thing and check it out and get it going and see how well it works. You know, come in for a lot of useful things. Now another item he dropped off was this little soft plastic piece, and what this was is it's a flexible ice tray. But I never thought about it. This makes great parts holders. When you're tearing something down, you can put the different size screws in each one of the little container or components or whatever. So it makes nice for sorting your stuff out when you're tearing a piece of equipment down to work on it. And talking about components, he brought this along too, and wanted me to show y'all just what you get sometime when you buying components. Now if you look at this, you can see, I can get the camera to focus on it, it's a tantalum capacitor. Now move the tray out of the way, see if that would help with the focus. But yeah, as you can see, it's brand new, never used, and he bought some capacitors and started checking them out, and it was real interesting to see just what he found when he checked this capacitor. And like I say, you know, it's brand new out of the package. And as you can see, this capacitor checks as a diode. Brand new out of the package. It's always a good idea to check your components before you install them. And it almost makes me wonder if it was a fake. It's you know, it almost looks like it could have been a 1N 914 dipped in some epoxy to look like a capacitor. We might have to break this thing open one day and find out. But yeah, it'd be interesting to see just what's going on with that capacitor. But anyway, he dropped off something else I wanted to share with you. So let me reposition the camera and we'll take a look at this. And as Dave would say, the HP fanboys go wild. We have a, actually it's two pieces, and man, this thing is heavy. It like almost needed a crane to pick it up to put it up on the bench. But the top unit is the HP 851B spectrum analyzer display section, and the bottom unit is the 8551B spectrum analyzer RF section. So yeah, big, nice old HP test gear, good old spectrum analyzer. Now this unit dates back to about mid-60s, early to mid-60s. So it's been around for a while. It's has a triple conversion super heterodyne scanning receiver, and everything that is obtained on the bottom unit is displayed on the 851B display unit. Frequency range is 10 megahertz to 12 gigahertz. Has sweep widths from 10 kilohertz to 100 megahertz, and the bandwidth is from 1 kilohertz to 1 megahertz. So as you can see, we got this band control dial. When you turn the band control, you can see that the display actually changes to whatever scale or frequency range you're doing it through, and it's done through harmonics. So over here you can see we have our tune, and when you rotate this, you can see the needle is moving very slowly, but when you pull out on it and turn, it moves much faster. So you can go ahead and get it to the frequency you want, push it in, then you can fine tune it. We also have a oscillator tracking meter over here, and that's where you can center the frequency that you're receiving. Now, like any piece of test equipment that you get of this age, you do not turn it on. Don't even think about plugging it in until you get inside of it and do some testing and find out, you know, just what kind of shape it's in, because we don't know. As far as I can understand, this thing has been garage kept for quite a few years. I don't know how it was stored previously before the last owner had it. So, you know, never plug anything in. We're dealing with a lot of high voltages in this thing. This thing does have tubes in it. There is quite a bit of tubes in this unit. So, you know, there's high voltages in it. And, you know, anything that's been sitting around for a long time, we just don't want to plug it in and see what happens. So we're going to look at a few things before we even get into it, and see if we can find out what the health of this thing is. I've turned the unit around so we can look at the back of it, and you can see we do have all the cables to connect it up like it's supposed to be. Some of these cables are not in the best shape, so those will have to be replaced. A lot of frayed insulation. I don't know what kind of shape the wiring it is in. But notice here we see a cover that is missing, and if you look inside of this, you can see some tubes in there. But this fan has been added. I don't know if the original fan has went bad or not, but whoever done this was not thinking. As you can see here, the two wires for the fan, and this is a 120 volts, is running directly under that cover. They did not bother drilling a hole and running through it. They just run it through there and bolted the cover back on, which, you know, that is going to pinch those two wires. I don't know what some people are thinking when they do stuff like that. Not a very good thing. But to go ahead and start seeing how the health is of this thing, first thing we're going to do is pull the fuse from the display unit and have a look at it. And that is a 3 amp slow blow, and it appears to be intact. This unit is set for 115 volts. For the big yeah, 3 amps is correct. Now we'll pull the fuse from the RF deck, and the first thing we see, this fuse is blowed. So something has definitely happened inside of this unit and popped this fuse. It could even be this fan, who knows. Might go ahead and take this off and just look and see if it's pinched those 2 wires. I pulled this cover off, and sure enough, as you can see, it has really bit down on them wires real good, and it does look like it's cut right down to the wire itself, right through the insulation. Not a good thing. This is why you do not run wires like that. That can cause all kinds of bad things to happen. So for temporarily, I have desoldered the wires and ran them through this crack on the side with a piece of tubing around it and soldered them back to the fan. And the only reason I've done this is that we don't forget later on when we start testing this thing out and we do apply voltage to it, because we don't want nothing to cause any shorts. But we're probably going to be looking around and see if we find an original style fan to go back in this unit. I'm not sure what the original one looked at, but maybe we can go online and find some pictures of this and find out just what type of fan that HP did run in this. I have several that would probably fit in here like it's supposed to, but I'd like to get something close to the original. I think what I'm going to do now is go ahead and move the RF deck out and get a look at this display unit and see what's going on in it before we try to even power it up. And like I said, we already know that the RF deck has a blown fuse, so we need to determine what caused that fuse to blow. Alright, so to get inside this display unit, normally you would take out 4 screws, but there's only 2 in the top. And we'll go ahead and remove those. And then the top should slide right off. And there we are. You see over here on the power supply board, we got 3 large electrolytic capacitors. This is our low voltage supply board, and you can see there's several capacitors over here. Interesting. You can see one of the capacitors here has already blown and shot the end right out of it. There's a rubber plug on the positive side of the capacitor, and it has already blowed it out. And by looking at the top of the case, you can see right here where it's exploded with the case on. And that's one reason why you do not power up old equipment like this. So we already know we do have some bad capacitors. Okay, I'll turn the unit over on its side and we remove the bottom cover. First thing that sticks out is on this IF section, all these screws has been removed. There was only 3 screws holding this whole plate on. Now that's another giveaway. That means somebody has been in here working on this IF section or trying to troubleshoot it, and they never did put the screws back in it. So yeah, that's going to be a big concern in that. Now, you know, we probably can repair this thing as long as there's not any unattainable parts that's gone bad that we can't find or replace with a modern day part. But if you notice how the tube in this thing is completely encased in metal. Good you know, attention to detail on HP for doing this. They didn't want any signals to radiate from this tube and get into any of the other circuitry. And if you notice on the back of that sweep range control, it's got a ton of capacitors around it. All those will probably have to end up being replaced. You know, as old as this thing is, we can see a few capacitors up on this board. This one looks like it's kind of barged in. They have a single point terminal strip between the circuit board and here with this one cap in it. Probably needed a cap to feed something, so they just barged it in with a terminal strip. So here we have our vertical amp board. So there's a 1 megacycle bandpass filter over here. That's the input and the output. Again, showing the detail to the metal shield around the CRT. Be careful, too much torque may crack bulb. Clamp should be snug but not tight. And then over here on the side is the high voltage power supply board for the high voltage feeding the anode of the tube, and we can see some bunch of capacitors down in there. They're all small capacitors, no big capacitors, but we'll need to look at those and make sure that they're in good shape or replaced. And I think our first step is AC power in is in over here on this side. This is our transformer, so we're probably going to need to look at this board and see if anything is blown or cause that capacitor to pop the end off of it. It's probably just due to old age, but you know, if something else was to went out, like one of these ICs or transistors or something, could have caused this to happen. Do see a little bit of burning on the board. It looks like this resistor has been replaced, and one that was got some heat shrink put around it has been stuck up there, probably to help dissipate heat. Not sure. I've lifted the low voltage power supply board up, and you can see these two large cavities in here, and we can see someone has been in here doing some writing on them, so that means someone has been down into this section also. There's also a bunch of more electrolytics all back behind this little rail here and down here in the bottom that will have to be checked and replaced. I went ahead and went through the whole unit, checked all the capacitors out. I didn't see no need of recording that and boring y'all with just checking capacitors. And the only one that was actually bad was the one that had the end blowed out of it. So I replaced it with a new electrolytic. And I went through and I checked. I checked from here to ground to see if there was any shorts or something that would have caused this capacitor to blow, and I actually did not find nothing. So maybe, you know, it was just a bad capacitor. I don't know. I have my variac set up, and we're going to go ahead, and if you noticed, I have the line cord plugged in with the voltmeter on it, and I want to go ahead and bring the variac up and see where 115 volts is today, because I really don't want to go much past 115 volts on this piece of equipment. And it looks like it's on about 92. It's going to be 115 volts. So I can turn that back down to 0. We're going to go ahead and plug the unit in, and we'll bring it up on the variac real slowly just to see if we have anything. Okay, we'll go ahead and switch the load on, and we're going to start increasing the voltage. It's about 10%. Moves up to 20%, and we'll look after about every 10% to see if we see anything smoking or popping or whatever. Alright, that's 30%. Still no problems. That's 40%. After about 50%, things should start happening. And as you can see, I'm seeing a trace across the screen. And you can see the ripple in it because the voltage is so low. That's at 60%. 70%. Now it's moving out. The capacitors are charged up fully. It's at 80%. That's 90%. And that's 115 volts. And you can see that's the clipping intensity will brighten right up. Focus is working good and just about centered. Wow, that's surprising, just to see this thing coming to life. So I guess we can say that the display section is working. Now if we can get the RF deck to work, we might be in some business here. Go ahead and turn the voltage back off. And we'll take a look at the RF deck. I have the 8551 RF deck up here on the bench, and I've done removed the 4 screws out of the top cover. So we just want to slide it back, and you'll get to see the same thing I'm going to see for the first time. So we have a low voltage transformer. This is the primary transformer. I know, the filament transformer. And this is the main high voltage transformer. And Yes, I'm seeing all kinds of tubes in here, and it looks almost like this thing has been sitting somewhere where there's some moisture. Take a look at some of these coaxial cables. You can see that mold that has formed on these cables. And all down on all these cables. So all that's got to be cleaned up. It looks like it's mostly on the plastic stuff. You can see over here on this box, some type of caution: ensure seal before flight. Maybe that's something that's used in an airplane. I have no idea. I haven't even looked at the schematic yet or the manual. But yeah, all that mold is going to have to be cleaned off of these cables. Look right down in here. There's some vacuum tubes there. So let's go ahead and get the thing turned up on the side, and we'll take a look at the back of it, or the bottom side of it. Okay, I got it on the side and have the bottom off of it, and the first thing you can see in here is a set of 8068 tubes. Those tubes are used as they're octal tubes, and those are beam power tubes, and they're designed for series regulation. They handle up to about 3 kilovolts, 3.5 kilovolts, somewhere in that range. And the underside is much cleaner than the top side is. We can see another board here, and there's 2, 3, 4, 5, 6, 7, 8 little miniature tubes on it. Then there's one board over here by itself that has a tube on it there also. And those boards look like they're plug-in style boards. So it looks like if you was to remove this one screw and pull this connector, that board there should slide right out. Same thing with this board. Just remove these 2 screws and pull the caps off the top of these 2 tubes, and that board should slide out. That should make it very easy for servicing. Down here in the bottom you see the high voltage power supply board mounted on the very bottom with a shield behind it, and what looks like a piece of insulator behind that also. Up here in the top we have an AC line filter. Now, I remember reading quite a bit about HP equipment with line filters going bad, and that actually burns up and causes all kinds of problems. I've even seen it burn the back of units. Like I've seen 2 or 3 threads on the EEV blog about such things. So this is one of my first concerns about that fuse being blowed. So we'll have to get in there and look. This thing is going to take a lot of cleaning. When I turned it out, I saw you see this, what looks like sand falling out of it. So it looks like this was probably sitting directly on a concrete floor somewhere, in the way it looks. So So again, you know, the first thing that concerns me about blowing the fuse is this line filter. You know, is there a problem with it? Let's take a look at the schematic and I'll show you what I'm talking about. We're looking here at the schematic and you can see the AC mains input, and this block is that line filter assembly, and inside of it is 4 capacitors, 2 coils. But more concern to me, not only are these capacitors, is this RT1, which is a type of thermistor, and they have been known to break down, and you can see this directly in the hot side path of the AC mains right just before the fuse. So that thing does concern me a bit. So I'm going to go ahead and remove this line filter. I've got one of the screws out already, and we'll go ahead and take the last one out. And we can have a look at it. Now this is a sealed box, it's unserviceable, you can't really do anything to it. And here is that thermistor that I was talking about, right there on the edge at the end of that box. You know, I'm still trying to get used to this new camera. And looking at it, I think we may be finding the problem. If you look right here on the edge, you can see some discoloration right here. And that looks like it's been arcing before. Let me get it under the magnifying lamp so we can see it better. And sure enough, that was our smoking gun that has caused the fuse to blow. If you look right there, you can see where this thing has been arcing. And it was probably arcing to some, you know, between the 2 plates, and that was the exit. That easy just to find the problem what caused the fuse to blow. I did ohm across the line and I saw nothing, you know, no low ohms reading there, so that is what caused the fuse to blow. So that you know where we at, I'm doing this unit just like I did the other unit. I'm just going through it and checking some capacitors and stuff to see if anything is bad or whatever, see if I see anything that's obvious. Now on the thermistor, I do not have one of those thermistors, and like I say, that one is arcing. So what I've done, I soldered a 1/4 amp fuse across it, and that should prevent it from arcing, but if anything happens, that fuse will just go away. Now I pulled this board out and it has these all these transistors mounted on top of it, and it sits down in here like so, and this board is in between it. And when I pull this board out to look at these capacitors, I think you can probably already see this one is bulged out on the end. This one is starting to, this one and this one checked okay. So these are 22 microfarad at 250 volts, so both of these are going to have to be replaced right to start with. So I have to go ahead and find some replacements for those, because I would like to be able to do the same thing and get this piece and see if it'll come up and run. Okay, I went on through the 8551B RF deck, and I've checked all the components, you know, as far as capacitors, resistors that's overheating, and anything out of the obvious. And this unit now powers up, but it is not working. If you can look down here at the power switch, you can see even though we're in the on position, it is saying line standby. So it is not going into the on position. So that's probably a safety feature, keeps something from powering up that's having a problem. So what we'll have to do now is pull this thing down and go piece by piece, circuit by circuit inside of it, and do all the testing, looking at the different boards, signals, power rails, and making sure everything is up where it's supposed to be. Because yeah, this unit is just not going into operation. So we got a lot of work to do on this, and I'm not gonna do all that in this video. We'll just we'll pull a section, we'll start in the power supply and we'll work through that, and then we'll make a video out of that, and then we'll go on to the next section and we'll go through and rebuild it. Hopefully there's no will not be any unattainable parts that cannot be fixed. So I'm real happy to see that the display section is functioning now, and seems to be working. There's a few tests where I can put some signals into it to get some information up on the CRT, but we'll have to play around with that in the next video. And another thing is, I've only got the manual on PDF, and it's a lot easier to work through something like this with a printed manual. So I'm going to have to get the manual printed out also, because it's a lot to go through on this piece of equipment. But we'll rebuild this unit, then we'll go back through the display unit. We'll also get it rebuilt, get everything tested, aligned, and I think we might have a decent piece of equipment here. Now just to find somewhere in the shop to put it. Once it's working, it's probably going to go over on the old time workbench where the existing computer and tube tester is. I think it'll fit under that shelf pretty nicely. So big thanks to B-Bod for donating this to the radio shop. It should be a very fun piece of equipment to work through and get working. Again, a lot of cleaning up, polishing this metal, getting all the knobs clean, getting the inside clean, going through replacing any cables that are bad inside. So yeah, a lot of work to go through it, but I think it'll be fun. So this thing is designed to go in a rack. It has the L brackets on the side so you can mount it in a rack, but we're just going to put it under the other shelf on the other side. Like I say, I believe it will fit. If not, I might have to modify the shelf to get it under there. But anyway, it's going to be fun, so stick with me on this. Did not have a lot of time in the shop this week to do anything. I have unfortunately taken on another new role at work, and that is taking up a lot of time. My current supervisor has left the building. He went on to bigger and better things, so everything's kind of thrown in my hand at the moment. So You know, it'll take a couple of weeks. We'll get through this and we'll get back out here in the shop and start doing a whole lot more repairs. But in the meantime, you know, be looking for plenty more videos to come out on this thing. Like I say, I'm not going to try to tackle everything at one time. You know, we're just going to go through it circuit by circuit, piece by piece, until we get everything up and running. So anyway, I hope you enjoyed the look at this HP 851B spectrum analyzer and the 8551B RF deck. And to the next video, we'll see you then. Bye now.